next talk is about data sets for vehicle pedestrian interactions. And the presenter will be Dongfang Yang. And I introduced Dongfang in our first session, but let me do it again. Dongfang is an amazing PhD student in our group, and he will graduate very soon. So we are very sad about that. Uh, Dongfang, you can begin when you are ready.
Yeah, sure. And thanks, Dr. Akin, to introduce me again. So my name is Dongfang Yang, and I'm a PhD candidate from the Center for Automotive Research at Ohio State. And in the last talk, I will introduce a pedestrian trajectory dataset created by us. And the dataset is for the vehicle pedestrian interaction in shared spaces. So the background of the research is that mixed traffic scenarios, for example, the shared space or shared streets are indispensable components of the transportation systems. And the pedestrians are one of the most important participants. And if you look at these two figures, you will see lots of pedestrians in the shared space. And understanding the behavior of the pedestrian behaviors, specifically the crowded pedestrian behavior that interact with the vehicle, is very important. And this could assist the urban design analysis, or it can also improve pedestrian safety or benefit the autonomous driving in crowded scenarios. So we think that a data set for such pedestrian behavior would be helpful either for the academia or the industry. However, existing public pedestrian data sets do not cover such scenarios. So there are some existing data sets, but they either only covering the crowded pedestrian scenarios, but it's only for pedestrians, which means there is no vehicle. For example, there are ETH datasets and the UCY dataset. And some other datasets, they do contain vehicles, but the vehicle pedestrian interaction is kind of limited. And the examples could be the Stanford drone dataset and the Indy dataset. So based on this background, we created our own datasets. And as an overview, our contributions is that we basically created two separate datasets. And one dataset is called CITR dataset, which contains scenarios created by a series controlled experiments. And this could be used to study specific interaction patterns. And the other dataset is called DUT dataset. It contains real interaction scenarios on campus. And this is kind of like a supplement to the first dataset. And our dataset uses UAV as a recording equipment, so that there will be no pedestrian occlusion. And also our dataset has high quality, and the trajectories are kind of smooth, and it has a high FPS. And also our datasets are open sourced online, and if you are interested, you can access it through the GitHub repository. So in the following slides, I will go over the dataset by first introducing how the scenarios are created or selected, and second, I will introduce the methodology of extracting the trajectories, and last, I will show the created pedestrian trajectory. So first, let me introduce the CITR dataset. CITR, this dataset basically contains the scenarios created by the controlled experiments. And we have conducted this experiment at a parking lot near the Control and Intelligent Transportation Research Lab. So this is our lab. And that's why we call this dataset the CITR dataset. And we have employed a golf cart as a vehicle in the dataset. And we use UAV as a recording equipment. And the participants, the pedestrians here, are the members of our lab. And we have designed 6 fundamental scenarios that can be pairwisely compared. So this is the scenarios we have designed for the CITR dataset. It contains 6 types of types of scenarios. And the reason that I say it can be pairwisely compared is that if you look at the first two scenarios and the fourth and the fifth scenarios, they can be compared, and the comparison will be either the pedestrian flow is unidirectional or bidirectional. And similarly, if we contain the first column with the second column, we can compare the scenarios of that whether there is a vehicle or there is no vehicle. And again, similarly, we can compare the vehicle front interaction with the pedestrians or the back interaction with the pedestrians. So that's how we design scenarios of the CITR dataset. And for the second dataset, the DUT dataset, since these are real scenarios, so we have selected two locations on a campus, and the campus is the campus of Dalian University of Technology. So that's why this dataset is called DUT dataset. And similarly, we applied UAV as a recording equipment, and the location we have selected as illustrated in these two figures. The first location is an irregular intersection with an uncontrolled crosswalk, and the second location is a large open shared roundabout. So to extract the trajectories from the above scenarios, we have developed a computer vision based algorithm to extract these trajectories. So basically, the methodology goes through the following operations. And after we have obtained the raw video from the UAV, we first do the video stabilization. And the video stabilization is used to create the same video background so that the trajectory extraction performance can be improved. And this is done by using the first frame as a reference frame, and then for the following frames, we will match the backgrounds to that of the first frame. And to achieve this, we use the SIFT algorithm to find the matching point between the first reference frame and the other frame, and then we use the random sample consensus to find the transformation. And after we have created a stabilized video, then we will conduct the vehicle and the pedestrian tracking. And this was done by an algorithm called discriminative correlation filter with channel and spatial reliability. And this algorithm works perfectly with a fixed background. So that's why at the first step, we would like to stabilize the video first. And the next step is just to convert the trajectories in the image space to the world coordinates. And last, we have utilized the Kalman filter to remove the noise and smooth the trajectory. So as a result, for the CITR dataset, we have recorded in total 38 clips of the controlled experiments. And in this dataset, since we were conducting the controlled experiments, so each pedestrian has a unique ID. And in total, we have 340 pedestrian trajectories. And for the second dataset, the DUT dataset, in total, we have 70 clips of crosswalk scenario and the 11 clips of the shared roundabout scenarios. And in total, we have about 1,800 pedestrian trajectories. And here is a figure showing the quality of the extracted trajectories, and the dashed lines are the trajectories of vehicle, and other trajectories are for pedestrians. And to give you a more clear idea, this is a video demo of our created dataset. And this is a video for the CITR dataset. As you can see here, we are conducting control experiments. The vehicle will come from different directions and interact with these pedestrians. So this is a case of the lateral interaction. As you can see in this video, most of all of the pedestrians are perfectly tracked. So the trajectory is very accurate. The tracking is very accurate. And here's a video demo for the DUT dataset. And as you can see here, this is the first location, which is an irregular crosswalk. And there are lots of pedestrians interacting with the vehicle. Since this intersection is kind of irregular, so there's no priority for either the pedestrian or for the vehicle. So the pedestrians and the vehicles needs to kind of negotiate so that they can pass that area. And this is the second location for the DUT dataset. And this is an even more crowded scenario. And as you can see in this video, there are lots of pedestrians moving into different directions, and there may be multiple cars. So there could be multiple vehicle interaction with crowds of pedestrians. Okay, so that's basically the result of our created data set. And here in this slide, I just would like to mention the possible usage of this data set. So we could use this data set for the research of modeling the vehicle pedestrian interaction, as we have introduced in the first session of this workshop. And we could also use the data set to do some pedestrian trajectory prediction in crowded scenarios, especially under the influence of vehicle. And we could also use this for the crowd motion analysis, for example, the pedestrian flow analysis or the group behavior modeling. And specifically for if you use our CITR dataset, you can study the individual pedestrian characteristics. That is because the CITR dataset conducts control experiments, and we have in total 10 participants in the control experiments, and we were able to assign each pedestrian a unique ID. So this would be very helpful to study the pedestrian characteristics. Okay, so as a conclusion, for this work, we have proposed two data sets. One called CITR datasets, which contains the scenarios of control experiments. The other is called DUT datasets, which contains the real campus scenarios. And this is to basically support the study of crowded pedestrians that are interact with vehicles. And we think this work has filled the gap that existing works do not cover such scenarios. And the future work could be expand this data set to more locations, and so that we can add in more variation. And another future work could be benchmarking some methodologies of vehicle pedestrian interaction using our data set. And again, our data set is publicly available online, and you can access it through the GitHub. And if you are interested in more details, you can check our publication. Yeah, so that's all of this talk, and thanks for your listening. If you have any questions, feel free to ask.
Thank you very much, Dongfang. Thank you for the amazing presentation. Do we have any questions? We have almost 7 minutes. So let me begin with a simple question. You introduced two data sets that you collected. Can you briefly explain the main difference between a controlled experiment and a data set that is collected in a controlled environment, and you compare that to a naturalistic data set?
Okay, so
why do we have two different data sets here?
So first of all, the motivation is quite different. So as you can see in the controlled experiments, we have different types of scenarios. And these scenarios are kind of typical vehicle pedestrian interaction scenarios. So as you can see from this figure, we have lateral interaction, or we have front interaction, or back interaction. So those are the typical scenarios. And I believe that if we want to study the interaction between pedestrians and vehicles, it would be better to start with some basic interaction patterns. And then after we somehow study the basic interaction patterns, then we can move to the second type of scenarios, which is real scenarios, because the real scenarios is extremely complex. And if you directly start with the extremely complex scenarios, it might be challenging. So that's why we would like to propose another controlled experiment data set so that it can help the basic studies. I mean, as a preliminary study or as a first stage study for the vehicle pedestrian interaction.
Thank you, Dongfang. So for our audience, you can use the QA button on the bottom of the Zoom application to ask questions, or you can use the chat also. Do we have any other questions? So data sets are extremely important, right? And we already have pedestrian data sets such as the Stanford data sets and commonly used data sets. But another contribution of your work is, I believe, it's the vehicle interaction. Is that correct?
Yes. So the focus of this data set is that first of all, we focus on the vehicle interaction. And this is a vehicle interaction with multiple pedestrian. I mean, lots of pedestrian, not just one or two. So as you may notice, I mean, this is a very small figure. In the Stanford joint data set, there do have some vehicle pedestrian interaction, but it's only like one or two pedestrian that are interacting with a vehicle. But in reality, there might be cases that multiple pedestrians interact with a vehicle simultaneously. So that's a challenging scenario, but it do happens in the real world. And so either for the autonomous vehicle or for the city planners, they do need to handle such scenarios. But since we were lack of such a data set, so that's why we have proposed this data set and created it for the usage of the whole academia.
Thank you, Dongfang. We have a question from David Zuby. The question is, will the UIT data set generalize to interactions in different parts of the world?
Yeah, actually, that's a good question. So right now, we don't have that many scenarios. So this
right now, it's only in China, right?
Right now it's only in China. This is a campus from Dalian University of Technologies in China. But we can use the same techniques to create more data sets if we have the resource to collect that many data sets. Of course, I believe that data sets from different countries, different culture will be definitely helpful for for the vehicle pedestrian interaction.
So another contribution is your methodology, because even though you have not collected data from all around the world, you introduce this methodology and people can just use this in Germany or in the United States.
Yes. So the methodology is basically using a UAV, and we want to stabilize the video so that it can has a fixed background. And once we have a fixed background, even a classical pedestrian tracker can perform very well, and it can give us high quality trajectories.
Thank you, Dongfang. We have 2 minutes.
I think that's enough to thank everybody who attended. And we really appreciate the attendance from all over the world, and look forward to any interest shown by the audience to collaborate in the future to expand any and all parts of all the presentations. And my personal thanks go to Professor Chi Chen, who attended, and all of the individuals associated with my lab. Thanks.
Thank you. Thank you, Professor Osguner.
Thanks.
So we have 10 more minutes for open discussion. We will be here until 3:30. If you want to talk with us individually, you can use chat, or we can have a general discussion. So I guess the main emphasis is pedestrians are vulnerable, and we need to take extra caution and extra care when we consider urban autonomous driving, because pedestrians are very vulnerable, and we need to spend extra effort for investigating every single edge case, and there are still many open problems in this topic. So we look forward to collaborate, and we hope that this small workshop, could encourage more research in this direction. So we have a comment from Even Law. Even Law points that how can we, give some extra information about simulation from the vehicle side? So as a tangent for that comment, even I agree. Another topic is testing. What should our testing standards should be, both from the vehicle side and from the pedestrian side. Real world testing standards and simulation environment standards, both are very important. And today's workshop mainly focused on real world data and real world behavior analysis, but one other tangent to this problem is controlled testing for regulation and testing purposes. And thank you very much for sharing this interesting video. Thank you, Eben. We have a question from Matt. Matt asks, like obscured pedestrian case, any work in developing a confidence accompanying the sensor data fusion outcome that might trigger a more cautious rate of driving when the perception is less certain? Does anyone wants to take that question? Matt, I think you just hit the head of the nail with that question. I think it's one of the most important problems in autonomous driving. It is uncertainty, how certain we are with our perception, how certain we are with our models, and we must include uncertainty in all of these algorithms so that we can behave and react differently when we have high uncertainty.